Okay, here we have this sequence, and we'll see if this right here converges or not, and then we'll see if this right here converges or not. And notice this is just a series. In another word, we will add up everybody from there. Anyway, let's come up with the explicit formula for this guy right here. Notice that on the top, we just keep adding 1. On the bottom, we just keep adding 4. Therefore, we have arithmetic on the top and also arithmetic sequence on the bottom. So, to do that, in fact, I'll show you guys the quick way to do this first, right? An equals, on the top, because the common difference is always 1, so we have 1. Remember, the common difference is a coefficient, and we multiply by n, and then we add it with, okay, when n is equal to 1, put it here, 1 times 1 is 1. We have to add what to get to 7? 6, right? So we just put on plus 6, just like that. All right, that's it. And then on the bottom here, the common difference is 4, so we know that the coefficient right here is 4, and then multiply by n, and we add. When n is 1, 1 times 4 is 4. 4 plus 11 will give us 15. So just add 11 to it. This is the quickest way to do it. And if you would like to use the formula way, let me just write this down right here for you guys. An equals, on the top, I will have to put down 7, which is the first term, and then we add it with n minus 1 times the common difference, which is 1, right? And then on the bottom, to put down the first term, which is 15, and then we add it with n minus 1 times the common difference, which is 4. So you do your algebra, you end up with this anyway, and you can just show me this on the exam. It's much better, in my opinion. All right, this is the an formula. Does this converge though? Well, we have to take the limit, so we have to check the limit as n goes to infinity of this expression, namely n plus 6 over 4n plus 11. And notice that on the top we have a linear situation, likewise for the bottom. We just care about this and care about that because they are the dominating parts when n goes to infinity, right? They are the big boss. And we end up with n over 4n, cancel the n, namely we just get 1 over 4. So the answer for this right here is an does converge, and converges to 1 over 4. And we are done for this part. And now, when we get the limit of an goes to 1 over 4, what can we say about this right here? This 1 over 4 is a happy face because this right here diverges since this right here is not equal to 0. That's it. You don't have to do anything fancy. And here's the idea. Remember, when we are doing this, the summation, this is telling us to add up everybody from the sequence. So it is the question that we have to do. 7 over 15 plus 8 over 19 plus 9 over 23 plus 10 over 27 plus 11 over 31 plus ... right? And again, over there, we have done the limit right here already. And the idea is that eventually, we are just adding bunch of the numbers, and these numbers right here, it's approximately 1 over 4. So you can just imagine we're just adding a lot of 1 over 4 after a certain point, and so on, so on, so on. And when you're adding up infinitely of 1 over 4s, this right here will of course go to infinity. In another word, this right here diverges. And let me just show you guys. You are going to encounter the sum as n goes from 1 to infinity of that expression, n plus 6 over 4n plus 11. This is the more typical question you have to deal with. I will tell you this right here diverges, and the reason is because by the test for divergence. And this is all you have to put down because over there we have seen that, right? So this is because the limit as n goes to infinity of this n plus 6 over 4n plus 11, this was equal to 1 over 4 that we did over there. And 1 over 4 is crucial because this right here is not equal to 0. So you can use the test for divergence and to argue that this right here diverges. So all this will add up to infinity, and that's the idea, right? And I need to get a new blue marker, but anyway, this right here is it.